The addition method, which used to be called the elimination method, is a very good method for you to know as well. And I would use this method quite often when the substitution method is not so nice if you don't have a variable with a coefficient of 1. So how do we do the addition method? Well, you're going to multiply each term of one or both equations by a constant so that the coefficients of one of the variables differs only by a sign. Now what do I mean by that? Well, if this is a positive 1, you want this to be a negative 1. If this is a 2, you'd want the coefficient up here to be a negative 2. Up here we have a 5 and a 7, so how are we going to make those be the same? Well, we're going to have to multiply something by both equations. So we're just trying to get them to be the same number but differing by a sign. Then you're going to add the equations together to eliminate one of the variables, and that's why it used to be called the elimination method. You're going to back substitute after you solve for the variable from eliminating. You're going to then back substitute to find the other missing variable. And then again, you get to check and make sure that your solution satisfies all of the original equations. Make sure you're checking by plugging it into both. So now again, I'm specific. I want you to solve by the addition method. Again, if you get infinitely many solutions, we're going to use set notation to express it. So we're not going to do the substitution method, we're going to do the addition method. So we look to see if one of them already differs by a sign, and we do see that we have x and negative x. So all I need to do is add the two equations together. So those are going to cancel, the x's go away, and 2y plus a negative y gives me y, and 4 minus 3 is 1. So sometimes it works out really nicely. So y is 1, so in my ordered pair, y is going to be 1. But what do I do next? I need to substitute back into one of the equations to find the other variable. And it doesn't matter which one because it should satisfy both. So I'll just plug it into the first one and I get x minus parentheses 1 equals 4. Again, I love using parentheses just in case something has to be distributed. It doesn't, so we get x minus 1 equaling 4. So x is going to equal 5. So our ordered pair, these do intersect at 5, 1. So 5 minus 1 is 4. We get negative 5 plus 2, which is negative 3. So this does check. Use a calculator if you'd like. Now, guessing is not going to be credited. What we're wanting to make sure you understand how to do is the addition method. So you need to show the addition method here. Number 2. 5x minus 3y equals negative 11, and 7x plus 6y equals negative 12. You get to decide which variable is easiest to eliminate, the x's or the y's. Well, x's, the first number that 5 and 7 can both go into is 35. So I'd have to multiply this by 7 and this by negative 5 because the signs need to differ, or negative 7 and a positive 5. And that's a little bit much, but you could do it. The y's look a little bit easier to eliminate because this is a negative and a positive. Since this is a 6, all I need to do is multiply the first equation by 2 because then I'd get a negative 6y. Now make sure you multiply everything by 2. A lot of students forget to multiply the right side, but you can't change the equation, you're just multiplying every term by 2. So I get 10x minus 6y equals negative 22. And the second equation stays as is, 7x plus 6y equals negative 12. Now why do we do that? Because now we have a variable differing only by a sign. So we're going to add the equations together. Again, that's step 2, add, to get rid of one of our variables. And we end up with 17x, the y's disappear, and negative 22 minus 12 gives me negative 34. And if I divide by 17, I'm going to get x equaling negative 2. So in my ordered pair, I get negative 2 comma something. So let's figure out what the something is. Plugging in the negative 2, you could plug it into the first equation or the second equation. Either one doesn't matter. I'll just plug it into the first. So 5 times negative 2, again using parentheses, equals negative 3y. I'm sorry, minus 3y equals negative 11. So 5 times negative 2 is negative 10. We're going to add over the 10. So negative 3y equals negative 1. We divide by negative 3, and we know that two negatives make a positive when dividing, so we end up with positive 1/3. So my answer is negative 2 comma 1/3. Use your calculator and plug in a negative 2 and a 1/3 and it will equal negative 11. Plug in a negative 2 and a 1/3 and you're going to equal negative 12. All right, so number 3, fractions again. Yes, they're going to continue popping up, so make sure you can get used to using them. Because we have an equal sign, I think the easier way to start this problem off is just multiplying by the LCD on the first equation and the LCD for the second equation, so we can get rid of fractions. Then we can start the addition method. The first number 2 and 3 can both go into is 6, so we're going to multiply by 6 over 1. So the first equation turns out to be 6 divided by 2 is 3, so I get 3x. 6 divided by 3 is 2, so I get 2y. 6 times 2 is 12, but divided by 3 is 4. And 15 can all go into is 15. So 15 times 2 is 30, but divided by 3 is 6. I'm sorry, 10. Don't know why I said 6. Let me change that. So 15 times 2 is 30, but divided by 3 is 10, so 10x. 15 times 2 is 30, but divided by 5 is 6. There is where I was getting the 6. And 15 times 14, but divided by 15, the 15's cancel, and I just get 14. So I get 10x plus 6y equals 14 for the second equation. So which variable looks easier to eliminate? The 3 x's with a 3 and a 10, or the y's with a 2 and a 6? I think the y's look easier. All I need to do is multiply the first equation by -3, because that would turn into -6, so when I added they would cancel. So I definitely want to multiply every term by -3, so we'll come down here. We get a -9x, a -6y equals a -12. Second equation stays the same, so we get -10x plus 6y equals 14. So we're going to add the two equations together. I'm sorry, that would be a positive. We're going to add the two equations together, so we get x, the y's cancel, and it equals 2. So in my ordered pair right now, I have 2 comma something. Well, what's the something? You got to solve for y. So just because we solve for x doesn't mean we're done. How do we solve for y? We're going to plug in x being 2. You could go to one of these hard equations where you have fractions, but I would probably stay in one of the easier ones where you don't have fractions. So let's go and plug in a 2 for the first equation. So we're going to get 3 times 2 plus 2y equals 4. 3 times 2 is 6, so 6 plus 2y equals 4. Then we're going to subtract over the 6, so 2y is going to equal -2. So y is going to equal -1. So these are intersecting lines, and they intersect at 2, -1. So let's look at number 4. X minus y equals 5, and -2x plus 2y equals -10. You could do the substitution method, but we're practicing the addition method, so I'm going to multiply the top by 2, because I see that if I multiply the top by 2, then I'll have a +2 and a -2, and those would cancel. So distributing all the way across, I get 2x minus 2y equals 10, and the second equation stays as is, -2x plus 2y equals -10. And we're going to add those two equations together. So those cancel, 0. Those cancel, 0. And 10 minus 10 is 0. So again, if we cancel everything out with our variables and we're left with just numbers, if it's a true equation, this is true, then you're going to have infinitely many solutions. And it asks for us to write it with set notation. So it's a set of all x, y's. Draw your line down that means such that, and write one of the equations, because they really are the same equation, just written in a different way. So I'll just write the first one, x minus y equals 5. Alright, so now you get to solve using any method you want. So this is where you get to choose. Do you want to do the addition method, or do you want to do the substitution method? What I suggest is, if you don't have a coefficient of 1, don't do substitution. So for number 1, I would not do substitution. I would definitely do the addition method. Why? Because none of them have a coefficient of 1. Same thing on number 2. I would do the addition method, because none of them have a coefficient of 1. On number 3, you could try substitution or the addition, but the only one you could substitute for is this x. And then number 4, again, I would not do substitution. So most of these are going to be the addition method unless you just want to work with fractions, which most of us don't want to, so I wouldn't do it. Alright, so looking at number 1, I will do number 1 with you, and then I'm going to assign the rest of you to try on your own. So number 1, we see that x's looked a little bit easier to eliminate than the y's, just by multiplying the first equation by a -2, because then that would give me -6. So go ahead and multiply all the way across. So the first equation becomes a -6x plus 8y equals a -14. Second equation stays the same, 6x minus 3y equals 4, and we're going to add those together. Again, the reason why I multiplied by -2 is now that those x's will cancel when we add, and we get a 5y equaling a -10. So we need to just divide by 5, and y is going to equal -2. So in my ordered pair, I have y being -2. So now I need to solve for x. To solve for x, we're going to plug it back into one of the equations. Again, it doesn't matter which one, because it should satisfy either one. So we have 3x minus 4 parentheses, always use parentheses when you're substituting, -2, and it equals 7. So we get equaling 7. Subtract over the 8, we get a -1. So x equals -1/3. So my ordered pair is -1/3, comma, -2. Again, use a calculator, plugging it back in, and those intersection points should satisfy both of those lines. So on number 2, we have 3x plus 4y equaling 5, and 9x plus 12y equaling 15. I'm going to let you try that one on your own. On number 3, we have x plus 4y equaling 1 and 3x plus 8y equals 4. You can decide to do substitution or the addition method. I will give you the answer for this one, and it should be 2, -1/4. And number 4, I'm just going to see if you can do it, and you should be able to check your answer if you're right or not just by plugging it back in to the equations and make sure it satisfies both. So you can certainly check that yourself without giving the answer from me. So